Lungang proves differentiation, tangents, convex, concave, all of that good stuff, all in one. I'm going to show you how we do it. It's actually pretty simple. Let's go. A curve has equation y equals a to the power of 3x squared, where a is a constant, a is bigger than 1. Show that dy by dx is 6x a to the 3x squared ln a. For 3 marks. Now, if this was a function within a wider question on its own, you can actually prove this in one step, or just compute in one step. But they want you to show it. So how do we do that? Differentiation, obviously. To find the gradient function, we're going to start with y equals a to 3x squared. Now, if you want, you could do the one way is you rewrite this as ln of e to the power, and then you go that route, or sorry, other way around, e to the power of ln, then you bring down the power, that kind of stuff. I don't really like that method. I'm going to do the ln method. You ln both sides, so you get ln y is ln of a to the power of 3x squared, and we bring down that power. So we get ln y is, using our log rules, 3x squared ln a. And then we differentiate implicitly. So we differentiate with respect to x. Now ln y, if that said ln x, that differentiates to 1 over x. So ln y differentiates to 1 over y. But because you're differentiating y with respect to x, you have to multiply by dy dx. Then we have to differentiate this. Now 3 ln a is just a number. Imagine that said 3 ln 2, 3 ln 3, whatever. That's a number. It doesn't make a difference in terms of the differentiation. We're only differentiating x squared. So we bring down the power, knock 1 off the power. Bring down the 2, 6, knock 1 off the power. And that's it. Now we're going to multiply through by y and replace y with this. And there's your 6x, there's your y, and there's your ln a. Let's just be very clear when doing an exam. That's the case. So I multiply by y and I just put it in the same place as the answer wanted it. So we get that, a to the power of 3x squared ln a, and that's proved. It says the tangent at this point passes through this, find the exact value of a. All right, I'm not sure if I'll be able to fit it here, because it's worth 4 marks, so, but we'll see. It says the tangent, okay, at 1a cubed. So tangent means gradient, means dy by dx at this point. Now our dy by dx is in terms of x, so we're going to sub in x is 1. So dy by dx at x is 1 is 6 times a to the power of 1 squared, so just 3 times ln a. Okay? And then we're going to do y minus y1. Yeah, so we're going to do y minus, the y coordinate is a cubed, is the gradient 6a cubed ln a times x minus the x coordinate, which you already knew is 1. Now you do not need to clean this up because we know it passes through half 0. We just sub it in and we can solve for a. Okay, so subbing in a half 0, we get the y being 0, we get minus a cubed is 6a cubed ln a x minus 1. Okay, now here we can divide by a cubed. Now we have to be careful because dividing by a cubed means you're getting rid of a solution. That solution is a is 0, but a is bigger than 1, so we're all good. Yeah, so divided by a cubed, boom, we get minus 1 is 6 ln a, and here, what happened there? I swear it was supposed to be a half. Yeah, we have a half. Yeah, the y was 0, x a half minus 1. A half minus 1 is minus a half, which is actually really nice because then these cancel. Times by 2, divide by 6. So times by 2, divide by 6, 2 over 6, a third is ln a. Then we do the opposite, we e to the power both sides. A is e to the power of a third. Sweet, mate. Show that the curve is convex for all x. That's like mathematical notation for all. All right, now the question hasn't specified if they want us to do it in terms of a or in terms of our actual value. But it doesn't matter, yeah, because if you do it in terms of the actual value, you can just utilize a anyway. So it makes no difference. Let's just do it in terms of a. In fact, I'm going to, actually it doesn't matter because we have the gradient. How do you prove something is convex? Well, convex, I'll just remind you of the shapes of graphs. I always forget, well, not really, but I always remind myself, if I was in an exam, I would remind myself, because I'm doing this on YouTube, I'm going to pretend like I'm in an exam because I really just don't want to re-record this. So, Neil does mistakes in that. So if you have a curve like this is what you should do in the exam if you forget. This section here, I think of it as it is caving in. This is concave. Okay? This makes a V shape, convex. And when you change from concave to convex, you have your inflection. Okay? Convex, minimum point. Minimum is when the second derivative is bigger than 0. Okay. So we just need to differentiate this again and prove it's always positive. Okay. So this is a cheeky 5-mark question. d2y by dx squared. Now, this is a cheeky product rule because we have x and x. Now, what am I going to take to be my two terms? That ln a, we can actually keep on the outside. Yeah, forget about it. It's a constant multiplier. So, differentiate the first term times the second plus differentiate the second term, which you already know is this. So 6x a 3x squared ln a. Yeah, so differentiate the first times the second, differentiate the second times the first. We need to prove that that is always positive. Well, immediately I could factorize out a to the power of 3x squared. So we get a to the power of 3x squared ln a. You can actually take out a 6 as well. Let's do that. We might be able to take out more. Let's just do what we can see. So this would go, so 6, those of that will go, we're left with 1. And then we're taking out 6 and that, right? So we're left with x ln a plus x ln a times 6x. Yeah, that's clean right there. 6, that, yeah. So you have x squared, 6x squared. Don't need the square bracket anymore. 1 plus 6 x squared ln a. Now from here we can make a description, right? So if you want, you could sub in, what was it? It was a was e to the power of a third, right? Or you could say for a being bigger than 1, ln a is bigger than 0. Yeah, because ln of 1 is 0. So for a being bigger than 1, I think this is better. For a bigger than 1, ln a is bigger than 0. Okay, the ln graph looks like this. 1, yeah? Ln of 1 is 0. If a is bigger than 1, it is bigger than 0. All right, so you've spoken about this. We obviously have x squared is always positive. Yeah, so x squared is always bigger than or equal to 0. And then this, what about this? Let's do it here. Well, a to the power of a positive number. So we have a to the power of a positive number. A itself is positive, okay? So this base number is bigger than 1. So it's a growing exponential this way to a positive power. So that must mean that this is at least 1. Yeah? So if this is 1 or more, and this is at least 0, if you have 1 to the power of 0, those are the smallest values they could both be. You have 1 to the power of 0, which is just 1. Okay, so if we consider the minimum value, so the minimum of d2y by dx squared, we get 6 times 1 times, well, that has to be bigger than 0, okay? So it has to be bigger than 0. So I'm just going to put 0. Well, that just means it then has to just be bigger than 0, right? So here I found that the second derivative is at least 0, all right? Now, do you think that's rigorous enough? Maybe not. I don't really like the fact that I'm saying it's just bigger than 0, which is what we wanted to do. Maybe I'll just say then that this is positive. What about this? This then has to be at least 1, okay? So if this here is bigger than or equal to 0, this bracket needs to be at least 1. So let's say that. Therefore, 6a to the power of 3x squared ln a has to be bigger than 0. Yeah, because that's at least 1 and that's bigger than 0. And this has to be at least 1. Okay, can it equal 1? It can. Which then leads to actually this just being bigger than 0 anyway. Therefore, d2y by dx squared is larger than 0. Therefore, always convex. Yeah, I'm happy with that. I just probably wanted to be a bit more specific with this section here. Not talking about just the individuals, talking about the overall problem as well. So it requires a bit of explanation there. But guys, a really important question. If you learned something today, I'd appreciate if you hit a thumbs up. Subscribe for more maths content. If you're interested in my A-level maths courses, more details in the description. If you want to join the Lun Gang Reddit page to submit your own questions for a chance to be on my YouTube or my TikTok, the link to that is in the description as well. I'll see you guys in the next video. Nice.